source transforms. First, let's remember the Thevenin and Norton. Remember Thevenin, you can draw a Thevenin equivalent for any circuit using one voltage source and one resistor, or let me say A prime, B prime. Or remember the Norton. You can draw a Norton equivalent for any circuit A double prime, B double prime, I Norton, R Norton. Okay, and they are the equivalent models for a linear circuit which contains linear components such as resistors, voltage sources, and current sources. You have 2 points from that circuit, points A and B, and you can draw a Thevenin equivalent for the circuit and or Norton equivalent for that circuit. Consider a circuit like that. Okay, that's V source and R1. Question: calculate the Norton's equivalent for that circuit. Or let me say this is Thevenin voltage and Thevenin resistance. Okay, calculate the Norton's equivalent for that circuit. Norton equivalent circuit. To calculate the Norton's equivalents, we have to do 2 steps. Step 1 is to calculate I Norton. And to calculate I Norton, we make a short circuit. We measure the current. That current will be the I Norton. Okay, that value will be the I Norton. And here, this current is the current of that resistor. Voltage of the resistor is V Thevenin. Resistance is R Thevenin. So this current will be equal to V Thevenin divided by R Thevenin. Okay. And step 2 is to calculate R Norton. And while calculating the resistance, Norton resistance, we have to turn the sources off. If you turn off a voltage source, it will be a short circuit like that. And there is a resistor, R Thevenin. Okay. And the total resistance that we can see here is R Norton, which is equal to R Thevenin. Okay, R Norton is equal to R Thevenin. So this is my actual circuit. I have calculated the Norton equivalent of that circuit. Norton equivalent of that circuit is 1 current source, 1 resistor, A prime, B prime. The value of current source is here This is the value of that current source. V thevenin divided by R thevenin, and the value of the resistance is here R thevenin. Okay. So if I have a circuit like that, I can replace that circuit with the circuit on the right. This circuit. Okay. This was a Thevenin to Norton transform. I had a Thevenin equivalent circuit. This is. I have transformed that circuit into a Norton's form, Norton equivalent circuit. And similarly, we can make a transform from a Norton's shape. For example, assume the original circuit is like that. Value is I Norton. The resistance value is R Norton. I have points A, B, and I can transform that shape into a Thevenin shape. A prime, B prime. Okay? And this will be Thevenin voltage, this will be Thevenin resistance. I can replace the shape on the right with this shape, but I have to calculate the proper values for Thevenin voltage and Thevenin resistance. Thevenin voltage is open circuit voltage, equal to open circuit voltage. Okay, you will calculate the voltage between points A and B. It will be the Thevenin value, this value. Okay, and Thevenin resistance is the resistance between A and B, while sources are off. Okay. After turning off the sources, you will measure the resistance between points A and B. And similarly, remember, I Norton is equal to the short circuit current, and R Norton is equal to resistance between A and B, while sources are off. Okay. So what's the open circuit voltage? Calculate the voltage between points A and B. Points A and B are the points of terminals of resistor. What's the voltage of that resistor? VAB equal to voltage of that resistor. Voltage of a resistor is resistance times the current on it, which will be the Thevenin voltage. And similarly, this is how to calculate Thevenin voltage, how to calculate Thevenin resistance. Similarly, turn the sources off. Turn sources off. Okay. So if you turn off a current source, it will be an open circuit. So what's the resistance between points A and B? That's equal to R Norton, this resistor. Okay. So if you have a Norton shaped circuit, one current source and one resistor in parallel, you can replace that circuit with a thevenin shape. Okay. And those values are equal to R Norton, and this voltage is equal to I Norton times R Norton. Okay, you can replace that circuit. So you can make that transform in two ways. If you have a circuit in thevenin shape or in Norton shape. Okay, you can make this transform in both shapes, both sides. This is I Norton, R Norton. If you know this, if you know the thevenin equivalent, you can calculate the Norton equivalent. If you know the Norton equivalent, you can calculate the thevenin equivalent. If you know the left side, you will say I Norton is equal to thevenin voltage divided by thevenin resistance, and R Norton is equal to R thevenin. If you know the right side, you can calculate the left side. V thevenin is equal to I Norton times R Norton. R thevenin is equal to R Norton. For example, question: find the voltage of AB, VAB, using the source transforms. Okay, you can calculate the voltage AB using lots of methods. Question: calculate VAB using source transforms. Okay, you have 3 minutes to calculate. For example, let me say this point is C, this is D. Okay, I copy this part. This is point C, this is point D. I transform this shape using the source transform techniques. I will draw a current source and a parallel resistor, and these points will be C and D. Okay. If I make this transform, resistors are always the same. This will be 5 ohm. Okay. And from voltage source to current source, remember I Norton was V thevenin divided by R thevenin. So I will divide the voltage source with the resistance. 10 divided by 5. What? This value is 10 divided by 5 is 2. So I will say 2 amps. And I will reject this part. Okay, I will reject this part. And instead, I will insert this part. Okay, this is my original circuit. My original circuit. I'm making a source transform. Okay, I will reject this part and insert the equivalent. Okay, and then I will continue to analyze the circuit. Now, here there is no resistors in parallel or in series, but after transform, I have 2 parallel resistors. I can reduce them. 5 paralleled with 5 is equal to 2.5 ohms. Okay, so if I redraw my circuit, 2 amps, 2.5 ohm, 2.5 ohm, 5 ohm, points A and B. And similarly, I will continue to transform between Norton and thevenin shape to reduce my circuits. Okay, now there is a Norton shape here. Okay, this is a Norton shape. I will reject it and replace with a thevenin shape. Let me reject that and calculate the thevenin equivalent. Okay, let me say EF, points EF. Calculate the thevenin equivalent. E prime, F prime. This voltage is voltage of the point EF, and that value is equal to current times this current times resistance. So it's equal to 5 volts, and resistors are always equal. Okay, 2.5 ohms, and this is the remaining part. Okay, or let me copy all parts. Okay, this is the complete circuit. I will reject this portion, reject, and insert the equivalent. Okay, so here these two resistors are in series. So I will, let me redraw the circuit. 5 volts, 5 ohms, 5 ohms, A and B. Okay, now again I can find a thevenin equivalent here. I can replace it with the Norton's equivalent. Okay, so Norton's equivalent will be something like that. For example, let me say this is point H, this is point I. Okay, so this is point H, this is point I. I'm replacing the thevenin circuit with a Norton circuit, and the current value is voltage divided by resistance. Okay, voltage is 5 volts, I Norton, voltage is 5 volts, thevenin is 5 ohm, so it will be 1, okay, 1 amp. And resistance will be the same, R Norton is always equal to R thevenin, so this is 5 ohm. Then the remaining part is this. Okay, I will connect it here, and then these two are in parallel. I can combine them. Five paralleled with 5 is 2.5 ohm, 2.5 ohm, and these points A and B. Okay, and then voltage AB. Question is, what's voltage AB? Voltage AB is the voltage of resistor. Voltage of resistor is resistance times the current, 2.5 volts. Sorry, I have forgotten one resistor here. Look, there is a 2.5 ohm resistor, but I have forgotten to draw here. Okay, so there is a 2.5 ohms, and here there is a 2.5 and 2.5. Okay, again there is a 2.5, so there is a 2.5. I have forgotten these, so I'm correcting the result. Now I can apply one more transform, and I can say, let's calculate the thevenin equivalent of this part. Okay. Let me copy that part. Okay. So this voltage will be 2.5 volts. Okay. And this resistance will be 2.5 ohms. So this is my circuit. This is the original circuit, and I will replace some part of the circuit. Okay, I'm rejecting that part. Reject that part and replace with the equivalent model. Okay. Now I can make a combination. These two are in series now. 2.5 volts and 5 ohm resistance. These are point A and B. Okay.